So just wanted to thank everyone for joining us for our second protocol town hall. It's been a busy few months as we ramp up on the foundation side and also ramp up our governance processes. So thank you for joining us. Just going over the agenda for today, we do have a packed meeting. So we'll first start off with some protocol updates, get an overview of GIP 2 and 3, and then we have a few people presenting on potential future updates. Then we'll have Yaniv go over network migration roadmap and what's expected over the next few months. And then we'll give an overview of the foundation and do a bit of a show and tell with some of the grantees at the end, and hopefully leave some time for Q&A. That sounds good. I'll pass it off to Brandon, who will do an overview of GIP 2 and 3.
Thanks, Eva. Yeah, I'll try and keep this quick since there's a lot of agenda to cover today. But the quick update on GIP 2 is that it's been updated, or the upgrade has gone to mainnet since the last time we spoke here. So that's the Graph's first protocol upgrade via decentralized governance, which is very exciting. It was a lot of work to get there. As you guys know, who are following closely, getting the Graph Council set up, getting a lot of the foundation operations set up, the snapshot community polls, the GIP process on Radical, and so on. And I think there's also a lot of really good conversation around GIP2 that kind of is already establishing like the norms that are going to, affect how future upgrades and proposals are handled. And I think it's great that the community kind of is starting to build that muscle already. The council met yesterday and kind of did a little bit of a postmortem on like GIP2 and how that process went. So there'll be some notes released on that later in the week. Some high level thoughts that I had were, we're constantly thinking about like what the principles are that are going to govern the network, and like obviously like each of us as community members contributing to like what those principles could be. And in the case of GIP2, I think a lot of folks brought up points related to maybe something I had written about before, which was like avoiding zero-sum games. And they kind of saw like, hey, GIP2 seems to like, benefit one stakeholder group, a little bit more than it benefits another. But I think the key part about GIP2 for me was that it also was incredibly important to the network as a whole, right? As the network's going into this, new migration phase, that's going to be absolutely critical for the, for the success of the network. And so I don't think on any single proposal, we're always going to like have this perfect scorecard where like every single thing hits every stakeholder group evenly. I think sometimes you'll do something for the benefit of the network as a whole, and maybe it benefits one stakeholder group a little bit more, maybe it benefits another. But I think holistically, as we look at the proposals, that we'll be researching on our end, I think you'll kind of get towards. I think you'll get a little bit more of that kind of evenness spread out across the stakeholder group. And and the example of that is we'll be switching some of our research attention to issues that delegators have brought up, in their interactions with the delegation market. And I think those are likely to, again, benefit the protocol as a whole, but maybe lean towards the delegators a little bit more. Some other takeaways were just that I think it's important to reiterate, and like the council kind of agreed with this, that, the snapshot community polls are just a poll. It's important for that expectation to be set up front so that we have, so that either the council or the foundation has the flexibility to poll the community on ideas that are still like work in progress. So if you look at like the GIP1 language, it basically shows snapshot community polls happening throughout the GIP process, like starting at like early draft all the way up to like candidate stage, where there's a candidate implementation. And so it's just important, it's totally fine that some protocols have this like direct token governance and that expectation is set up front. But I think the important thing here is just expectations that, right now, the way snapshot community polling is set up is that it's meant to be an information signal, but not this like direct, it's not like a referendum, right? And then the last thing is, I think it was frustrating for a lot of people in this process, including ourselves, to be moving so slow. We're used to moving in a very agile environment. I think a big part of that this time was audits seemed to be the constant bottleneck. So the updates on that are starting next month. We'll have a retainer set up with, this is through the foundation. We'll have a retainer set up with consensus diligence, and then there'll be a retainer starting with Open Zeppelin I believe the month after. And so from, kind of that point forward, there'll be a little bit more of a regular cadence of audits that are just kind of booked for the, booked for the graph's exclusive, use. And so we hope that'll make, a big impact in, keeping these things moving a little bit smoother in the future. Last update I have is more of just a housekeeping note, is that the audits for GIP3 have started this week. And so that's an update that you can expect in the near future. And there's a number of other proposals that you'll be hearing from folks on the call that are related to the subgraph migration. So that's another thing to keep an eye out for in the forums and in the snapshot community polls. And with that, I'll yield my time.
Awesome. Thank you so much, Brandon. So next up, we had a few people who want to discuss updates. Brandon, did you want to start off on that one as well?
I can introduce the ones at a high level if I know what you're referring to. So we have two that are related to the subgraph migration. So one of them is just related to making sure that the subgraph indexing process is fully deterministic, for the purpose of arbitration. And so right now we have something in the subgraphs that's a timeout. That's actually time-based, not gas-based, and that's subjective between indexers. So we have a proposal that Zach will be talking about to address that. And then we also, as part of our state channel solution that we're rolling out, we have a parameter update that's happening in the protocol, and Ariel will be talking about that. And I'll just hand it off to them.
Yeah. Hello. One of the changes we need to do in the as a parameter update in the protocol is to allow something that we call an asset holder to send funds to the staking contract. Currently, there's the source of funds being collected from state channels is something called the gateway. And by using the new vector state channels, what we need is to use a contract called a withdrawal helper. That is going to connect multiple, I would say, multi-sigs that is holding the collateral to the protocol. So we need to set this parameter into the contracts and staking contract. It's basically calling set asset holder with an address of a contract we're going to deploy and publish and verify in Etherscan.
Yeah, so the state channel solution is like kind of extra protocol, right? This is like this separate vector thing that Connect has been working on, and it's audited separately as part of that project. This is kind of just like an allow list to allow the integration of those payments to be settled into our protocol. And so Ariel's working on a GIP now. I don't believe it's in the repo, but I think it should be up later this week for folks to review.
Yeah, what you can find in the repo, the contract repo, are multiple different PRs. One of them is related to the withdrawal helper. You can see the code there. And the GIP that I'm going to write is related to explaining why we need that. Okay.
Awesome. We can move on, I guess, to Zach, who'll be talking about a WASM update.
Okay. Yep. So the other update that we have is a proposal to add gas to increase the determinism in subgraph execution. So one of our goals with the graph is that we would like to give the community the ability to upload their own subgraphs to mainnet for indexing. But in order to allow anyone to publish a subgraph securely, an indexer needs to have assurance that indexing isn't going to cost them an unbounded amount of resources. For example, imagine a subgraph where the code is just an infinite loop. If you could trick an indexer into indexing just a few infinite loops, that would steal a significant amount of resources from the indexer that are meant to index real value add subgraphs. So curation deals with this to some extent, but the problem is severe enough that an indexer should take this into their own hands as well and not really rely solely on curation for their security. So there's an existing mechanism in GraphNode to deal with this, which is a timeout. So after a configurable amount of time spent in handlers, GraphNode will cease indexing a subgraph and transition it into an error state. The problem with timeouts is that they're not deterministic. So two indexers running with different hardware or timeout configurations may reasonably disagree as to whether a subgraph did in fact time out. The question would be then, what do we provide as a response to a query, or what do we provide for a proof of indexing after that point? A non-option is that the indexers both provide responses and attestations to their responses. So if one indexer is saying that the subgraph timed out and the other not, then the attestations disagree. There can be a dispute, and in the worst case, slashing. Right? Nobody wants that. Instead, what's implemented today is that the indexer that timed out does not provide attestations or proof of indexing at all. So the indexer that progressed beyond the timeout, however, can still serve queries and proofs of indexing. And this seems reasonable, but it sets the stage for a rather insidious economic attack. So let's say that you have a malicious indexer and they want to claim exclusive indexing rewards that only they can collect. They may develop a subgraph that takes effectively forever to compute. So maybe it's not straightforward like an infinite loop, but it's something almost as bad, like brute forcing a winning strategy to the game of chess in a subgraph handler and then saving the winning strategy in an entity. This would take much more compute than is possible, and we can clearly know that no indexer is able to index that subgraph, and all honest indexers would time out. But what then if the malicious indexer submits a proof of indexing and collects rewards? Right? It's impossible in many cases for the network to prove that the indexer is acting maliciously. One cannot simply provide the correct proof of indexing because you can't compute it, nor can you provide an attestation for a dispute. So even worse is that showing that the correct value is uncomputable is equivalent to solving the halting problem, which is a famous unsolvable problem in computer science. And so in this scenario, the indexer claims the rewards, but does not give any utility back to the community. So that's a very long-winded, but hopefully educational introduction to a complex problem with a straightforward and easy solution. So what this GIP is going to propose is that specific costs be assigned to operations that a subgraph can perform. These costs are called gas. You're probably familiar with the concept from Ethereum. If a subgraph would use too much gas in a handler, it would deterministically stop executing. A deterministic error condition is attestable and disputable, which removes the previous loophole, allowing an indexer to claim exclusive rewards because nobody can call them on it. As for whether or not implementing some kind of gas is a good idea, this is practically a given. It's almost tautological that gas is the right answer to this problem. So I would expect that part of the GIP to go forward without much controversy. But within those bounds, there's a lot of design space and many important questions for the community to answer. So one of the first questions is, over what period is gas counted? Does it count per block? Does unused gas accumulate over time? When is it reset to zero? That kind of thing. The design that will be put forward in the GIP is to count gas individually per handler. And the reason for this is that it's a very bad thing generally for a subgraph to fail in surprising ways. So if the gas was counted per block, whether or not the subgraph would fail would depend on how many handlers ran in that block, which would be dependent on the popularity of the smart contracts and the changing block gas limit and other factors, right? But if instead the gas is counted per handler, it becomes much easier for the subgraph author to reason about. So if they can show within the limited scope of the handler that it never exceeds a gas limit, then they can have assurance that the subgraph should continue to work forever. Another question that the GIP is going to talk about is what the gas limit should be set to. But one option there would be to have the gas be configurable, right? A subgraph developer could finely tune the gas in a subgraph manifest according to the needs of that subgraph. This approach has some benefits. First, configurable gas means supporting a wider range of possible subgraphs than might be anticipated today. Furthermore, the gas limits specified by the subgraph developer could provide an important signal to indexers about the cost of indexing a subgraph. Indexers may then use this information when deciding whether or not to index a subgraph, or even maybe what hardware instance that would be best to index that subgraph on. This is unfortunately not the design that will be put forward in the proposal. Instead, the proposal specifies that the gas will be set to reasonable protocol-wide defaults. The reason for this is that it's better to have a reasonable gas limit sooner and add configurable gas later in a later GIP. So migrating toward having configuration options later is easy because we can use the current defaults if no gas limits are specified in the manifest. Adding a configuration may seem like a small task, but there's actually a lot of knobs and questions about what the right way to do configuration would be. There would be questions about whether we want to track gas separately per resource, like whether saving an entity or doing an Ethereum call or WASM compute would be tracked separately, maybe, or be questions about the naming and grouping of options inside the YAML file. And it's my expectation that these and other questions would generate a significant amount of discussion, but may not be the best area of focus for right now. So that's why I would go with sort of a reasonable default in this GIP. The answer to then about what to set the gas limit to right now, like what is the default configuration going to be, is just really high. The numbers need to be high enough to ensure that no major pre-existing subgraphs fail for gas reasons when migrating them to mainnet. So this answer kind of works well with our original motivations for adding gas, which the goal here wasn't to drive down the cost of indexing or to make indexing costs fair across subgraphs like it might be with Ethereum. You can do that already with query fees. Instead, the goal is just to make sure that disputes are always possible, as is necessary for migrating subgraphs to mainnet securely. So then the immediate follow-up question that an indexer might have is, if there's a really high gas limit, how are indexers protected really from expensive indexing costs? And my answer to that right now is that the GATS mechanism that we're introducing, or would propose to introduce, is not necessarily a substitute for the existing timeout mechanism. So it's still in the indexer's discretion to stop indexing at any time. You know, for example, if there's a timeout or if they deem that the indexing is too expensive for whatever reason. Right? Under those circumstances where the indexer and not the protocol decides to stop indexing, then the indexer would not serve requests or collect a proof of indexing for blocks that they have not yet indexed. So that's about it for the gas proposal. I hope that this provides some useful context for when the GIP hits the forums.
Great. And just one point for clarification is that this isn't proposing adding additional cost to the indexing. So this isn't like gas that users are paying for like they do in Ethereum. It's specifically to find a gas limit, which stops network level indexing of that subgraph to get these kind of pathological cases. And the costing side for the indexing is meant to be still recovered from query fees. So that's if there's a subgraph that's more expensive, you can see how much more resources it's using at indexing time via the gas mechanism, and you can also price then the queries accordingly to recoup your costs.
Yes, thanks for clarifying that, Yaniv.
Mm-hmm.
Awesome, and look to the forum for discussion on that GIP. Next up, we have Sebastian from Protofire to talk about indexer CLI updates.
Hey guys, I'm glad to be here. We have in more detail on a proposal of improvement for the CLI. I'm going to share my screen for a few minutes. Well, we shared a few improvement ideas a few weeks ago on the forum. It's been 2 years, or more than 2 years, since our team started working on Subgraph. Actually, I was the first member of that team. So I've been dealing with the tooling from the very beginning. So I'm one of the early stages users. So it has improved a lot, but we believe that we can even improve that to be more powerful and adding more features. We mainly focus on improvement that we can make just by changing the CLI code base and only the CLI code base. That means no changes required for the graph node, no touching anything else than the CLI. So I'm gonna go through the list. The main one is upgrading the assembly script version we use on the CLI. The current version is a version that is pegged to a really older version of the assembly script. That means a version from 2 years ago. For example, with the version, you can even convert convert a string to lowercase. You have to operate on bits, but on new version, for example, you can use a complete standard library string implementation. So we believe that this upgrading will provide a really better user experience for developers, for the Subgraph developer. That is our first proposal to upgrading the assembly script. There are a lot of another reasons to do that. For example, there are a lot of improvement on the standard library, more implementation for the user. So it's all winning. The second proposal is also extending the CLI to support importing schemas from another package. I mean, for example, importing a schema from another libraries like this. On the schema file, we will be able to import a schema defined on another package. We think that this feature will allow us to distribute more libraries to reuse many code through the different subgraph and to provide well-tested schemas to reuse on the different subgraph. The other ones are less important, but for example, right now we have some kind of templating workaround to deploy the same subgraph to different networks. We believe that like this, for example, you will use an external library, external template engine to render the different subgraph manifests. But we believe that this kind of feature should be part of the CLI. Well, we propose many other improvements, small improvements, but we know that there are here around many other experienced developers Subgraph. So feel free to take a look to this post. It's in the forum, and provide feedback if you want. Feedback is always welcome. So thank you. That's it.
Awesome. Thank you so much, Sebastian. And last but not least, we have Ariel to talk again about a few updates he's working on.
Okay, I will share my screen a bit. Yep. So I want to talk about one of the updates. Is related to a fix of how we initialize delegation parameters in the staking contract on a particular case. This was reported through a bounty, and we already have a fix that it's in this PR. You can read because there's a description of the issue. But I want to describe it. Basically, the issue is when you stake for the first time as an indexer, what you get is we initialize the delegation parameters. We set it to be most beneficial to the indexer, like 100% indexer cut. The issue is that when you use stake 2, that is a function on the protocol that we included for a third party to stake on a particular indexer address. This function is using set delegation parameters, and set delegation parameters is using the message sender. So the result is that we are not getting the right initialization of the delegation parameters in those cases. So this never happened in the protocol. Stake 2 is not very used now, and it's easily fixed by an indexer because you can use stake 2 and then set delegation parameters. But I want to talk about this so you are aware that this is happening, and I'm going to write the GIP for an upgrade of the staking contract with the fix. That's it.
Perfect. So if that's it for protocol updates, we'll move on now to network migration, and I'll hand it off to Yaniv.
Hey everyone. So yeah, it is time for subgraph migration. I think this is the thing that everybody's excited about. It's been a long time in the making. We've got about a year and a half's worth of work that we're going to be releasing, with this next set of releases. And we published a post a little over a week ago, kind of discussing the process. So I'll just kind of recap it here so everybody's on the same page. So the subgraph migration is going to take place in 3 phases. The first phase is the migration bootstrapping phase. And the idea is, there are a lot of participants, indexers, delegators, developers, and we don't want this to be too chaotic of a process. So we're going to help kind of coordinate to get the first set of subgraphs published on the network at around the same time. And so there will be an initial set of subgraphs, and those subgraphs will be what we call like over signaled. So the idea here is in the curation market, as more and more subgraphs get deployed to the network, the signal becomes a really important mechanism for knowing which subgraphs to index and for developers to know which subgraphs to use. But in the early days, when there's just a handful of subgraphs, the signal doesn't actually provide much additional value there, and there's actually like more risks of things becoming noisy in the early days. And so to just kind of like remove all of that noise, the subgraphs will initially be over signaled, which basically makes it so that there's no real incentive for curation to happen at that point. But at the start of the first phase, indexers will be able to start indexing those subgraphs and then start serving queries in the network against those subgraphs. So this is going to be something where Edge and Node works closely with the foundation and with this initial set of dApps to do this first wave. Once the subgraphs are synced, which for some subgraphs could take up to a few weeks, some might just be a few hours, the dApp teams will be able to start testing those subgraphs using an endpoint that uses the state channels implementation to do micropayments per query. Once those teams go through their internal QA processes, they'll be able to move on to the second phase, which is production dApps. And this is when they take their front end and they just point to the new endpoints that get routed to the decentralized network instead of the hosted service. And then after the second phase, we'll be able to see those dApps running in production. We're really excited to kind of see the performance of having, geographically distributed set of gateways all over the world, routing to a large diverse set of indexers that are, optimized for these different subgraphs. It should be a really exciting time to kind of see those, first production dApps on the network. And then we move to phase 3, which is Curation Live. And that's where, we'll be launching a set of products that make it really easy for anybody to publish their subgraphs to the decentralized network, pay for query fees in GRT, and also have the curation market UI, so the curators can start signaling on all the new subgraphs. The general kind of arrangement there for these kind of sets of products is it's something that the Edge and Node team is building. We have design, product, engineering expertise, and it's getting kind of white labeled to the foundation through the services agreement that's in place there. So those products will be integrated into the graph.com, and that creates kind of like a seamless experience for folks that go to the Graph website and can start browsing the Explorer and get started kind of with development and publishing to the network. So all of that's going to be an integrated experience. So that's kind of the process, and we're trying to balance here, getting this stuff out, as soon as we can, but also in an orderly way. I think it was really important for us to have this initial kind of bootstrapping period on the network. We're able to go through the initial governance process. We're able to really see everything running smoothly on mainnet, and now kind of do this transition. Really excited to work with everybody on this. If you're a dApp that's running on the hosted service right now, feel free to reach out to any of us to find out how you can be part of this early migration program. And I think it's something that'll be really exciting for folks to take part in.
Awesome, looking forward to it. And we've had so many curators with us along the journey since the testnet and curator program, so we're excited to have you guys along the ride for the next few months. So next up, we wanted to provide a few foundation updates. So I'll just share my screen quickly. So our focus the last few months has just been standing up the foundation itself and supporting the network bootstrapping. We've also done a big push on releasing $5 million allocated to the community. So this is across grants, foundation contributors, and ecosystem contributors. On the governance side, Brandon and the Graph Council have been doing an incredible job of standing up some of our processes. We've had our first protocol town hall last month, and we've also had a few GIPs pass. So creating that cadence of using the forum and Snapshot to really create a fruitful community and discussion around some of these updates. We've also announced multi-blockchain and have started on some of the EVM-based chains. So Binance Smart Chain, Phantom Fuse are a few of the ones that we've already released, and we've got several in the pipeline. One of the other exciting components of our community has been the educational rigor. So we've had 4 universities reach out to us to help develop courses on either how to build a subgraph and adapt together, how to become an indexer, or how to learn more about the future of work and contributing to open economies. So we're really excited to hone in there, and those are global. So you'll hear more from us, and maybe you can even participate in one of those courses in the future. And then just going over some of the grant highlights. So of the 5 million, approximately 2.5 million is attributed to grants. As you can see, protocol was one of our main focuses. We've got a few heavy hitters on the indexer performance side, and several automations to improve the ability for new indexers to join our ecosystem. On the tooling side, a lot of it is focused on monitoring, tooling, getting more information to indexers and delegators about the network, and also improving tooling for subgraphs. So one of the exciting ones here is creating a Python module. We've also got a subgraph testing framework and a query Chrome extension to make it easier for developers to share deep links of queries. On the dApps and subgraph side, we're across the board, so excited to see representation in NFTs, scaling, and also DeFi. One of the ones I'm most excited about is this decentralized Google Docs, because it's one of the first apps that's actually building on Saya and the Graph. So we as an ecosystem will learn a lot from that one. And on the community building side, to be frank, we were overwhelmed with the interest, to continue growing our community. So you can see we've got quite a few programs, either on the educational content, podcast, hackathon sponsorships, and lots of regional moderators that are just trying to build up the community and educate more folks about the Graph. And now we'll actually have a few of our grantees do some show and tell and talk about their grants. So maybe let's start off with Stefan from the Graph Academy.
All right, so thank you very much for giving me the opportunity today to present a little bit more about the Graph Academy. So I'm going to share my screen right now with you, because I've prepared a small presentation. I hope you can see it. And so what we want to build with the Graph Academy is that we want to foster a knowledgeable community. And what we want to provide is a community outlet for community members to participate in writing documentation about the Graph ecosystem. So the problem we identified in the Graph ecosystem is that we had many different outlets that produced content, documentation about the Graph ecosystem, but there was no single go-to resource where we could send new members of the ecosystem over so that they could get onboarded with the Graph easily. And the second challenge we identified was that onboarding new participants in the Graph ecosystem was quite a challenge, as the Graph ecosystem is quite complicated for new members, especially if they have no foundational cryptocurrency experiences. So what we want to provide is a forum or a community for these new participants in the network so that they can quickly accelerate the knowledge about the Graph ecosystem. And with the Graph Academy, we want to provide this single go-to resource where everybody can go to, from developers, from indexers, subgraph developers, delegators, and curators, to really grow their knowledge about the ecosystem. And there was an interesting discussion over at the Graph Discord that I've noticed. And this was this member who was a delegator to an indexer, and he made the wrong choice, and he delegated to an indexer that he did not receive any delegation rewards from. So instead of blaming himself and telling himself, well, I did not do the required due diligence that I had to do about the indexer, he was pretty disappointed about the entire Graph ecosystem. He was, and as he stated in the quote, he said that he was kind of done with the Graph. So this conversation made me realize that whenever we have onboarding problems in the ecosystem, it will always have a negative consequence for the entire ecosystem and for the brand. So this is why it's really important to help new community members to get onboarded and to provide this resource for these new community members. And this is why we have introduced the Graph Academy, and we want to build a free, open source and community-driven knowledge base for the community and by the community. And what we are doing is we have this two-tiered approach. So on the one hand, we have the Graph Academy, the main page, where we provide visually appealing guides, which are interactive step-by-step tutorials. And then we also have the content over at GitHub, which provides technical documentation about the ecosystem. So I'm going to show you in a second how this all works. And obviously, for everyone who's interested, this is an open invitation. Everybody is allowed, and we are very happy if people join the movement and help us or join us in the quest to become the go-to resource to master the Graph and to further reduce the barrier to building the infrastructure for Web3 applications. And so if you are right now writing technical documentation, we would love to see you committed to the Graph Academy Hub on GitHub, and everything that you publish over there will be automatically synchronized to the Graph Academy. So I'm going to show it to you right now how this all looks. This is the main page. And here you can find resources about the ecosystem for developers, for indexers, for delegators and curators, and a couple of video guides that we are working on right now. And for example, we could have a look at the Graph Delegator Knowledge Hub, which features a lot of tutorials for delegators to simply help delegators in getting started with the Graph. So we explain to them what the Graph network is, what a delegator is, the kind of risks they are confronted with and should take into consideration. And we also help them to choose indexers. And from there on, they can grow their knowledge about the ecosystem to more advanced subjects and stuff like this. So I'm also going to show you the documentation page. So this is, for example, the testnet Docker Compose guide by Payne. He published this over at GitHub, and everything was automatically synchronized to the Graph Academy website. And the main feature is that whatever you see here can be easily edited over on GitHub simply by clicking on the link. And if you click the link, you're being transferred over to the Graph Academy Hub, where you can make a pull request, and everything will be automatically synchronized over to the main website. So thank you very much for giving me the time to present today. And I will post right now in the chat a link for everyone who is interested in contributing to the Graph Academy. And I would love to see you over there in our Discord server. So thank you very much.
Awesome. Thank you so much, Stefan. Next up, we'll have Tommy Chan talking about a query Chrome extension tool.
Hey guys, Tommy here. I'm going to share my screen Eva, could you give me access?
You should be able to.
It says host disabled participant screen sharing. Oh, there we go. Okay, great. Yeah, hi everyone. My name is Tommy. I'm the core dev from APY Vision. And the grant that we got from the graph is going to be focused is used to be focused on building for AMMs. So, you know, there's in DeFi and crypto, there's a big focus on, you know, the TVL. It went from $2 billion to $50 billion just recently. But what you also need to know is that 30 to 40% of that TVL is actually locked up in decentralized exchanges and AMMs. And the current problem is that it's very hard for someone to come in and read an AMM. And what happens is, you know, they have to go on Uniswap, and then they have to go on Balancer. And the idea is that what we want to do is aggregate all of these AMMs and provide one consistent subgraph for people to query on. The reason why we are interested in that is because we've also run a tool called APY Vision, and we actually help liquidity providers basically tease out their gains and losses based on the pools they're in. And if you guys have done any LPing or liquidity providing, you'll see that, you know, you're bound to a lot of the fluctuations in price, and it's very hard for somebody to know what their gains are over the time that they're providing liquidity. And so API Vision is really there to help guide them through the stats as well as what their gains are and how they're doing so far. And so we wanted to create a subgraph to encompass not just the user data, but also more historical information so that people, other developers can help with the querying and also build on top of different AMMs. And so that's what we're going to be doing. And as you can see here, the list is quite long, but we will be focusing on the bigger AMMs first as a first cut. So Balancers, SushiSwap, Curve, 1inch, and then we'll be moving down the list. And so we'll have two subgraphs, one for generalized AMM data, which you know, includes price history, volumes, reserves, day history for various things. But then we'll also have a subgraph that will index specific user data. So a history of their enters and exits, what price they entered at, number of LP tokens that they acquired, also the gas that was paid and the fees that were collected as being part of an LP. So there's a lot of work here, but we've actually started building the subgraphs for our own use actually. So one of them was it's version 0, so it's still kind of ongoing, but the idea is that we start aggregating a lot of these data from different AMMs so that we can consume that data on the client side. So we're building it for we're open sourcing it for everyone's use, and we hope that, you know, people contribute to it and that we have one unified subgraph instead of, you know, calling 10 different places at the moment. So.
Awesome. And I also left a note that Tommy's team is also working on a query Chrome extension, so you can ping him about that. And last up, we have Chris Wessels talking about indexer agent improvements.
Cool. Hey, everyone. Thank you so much for the invitation to speak more about that today. Let me share my screen. Cool. Okay, so as part of my Wave 1 grant, I am working on improving the OpEx for indexes by reducing gas costs. And that is really coming down to better transaction orchestration inside indexer agent. So we look at kind of a scope of work for the grant. The first major task has been actually simulating some of the optimizations that we can make to the way in which Indexer Agent interacts with the protocol contracts on chain. And the learnings that come out of those simulations will then result in implementation work against Indexer Agent. And we'll look at kind of what that might look like in a second. And then potentially, also out of the simulations, we'll get some insights that may mean that we propose some GIPs to actually tweak the on-chain contracts and potentially significantly lower gas costs for indexes. So where does this gas cost footprint actually come from? Indexes obviously index subgraphs and generate proofs of indexing and serve queries and do all of the things they do off-chain. But naturally, they need to make on-chain interactions in order to participate in the protocol. And really, that footprint comes from two places, and that is managing allocations. So any subgraph that an indexer is indexing, they need to manage allocations for on-chain, and those allocations have a max lifetime of 28 days. And so, closing and opening and really managing that kind of set of allocations across the subgraphs that are being indexed is a significant source of gas cost for indexes. And then also actually claiming query fee rebates from the protocol also has a fair amount of gas costs attached to it. So today, Indexer Agent does this in a fairly simple and kind of dumb way, where it runs a reconciliation loop. So periodically, it basically asks, what are the rules that have been set? What is the set of subgraphs that I should be indexing? And then it compares that to what allocations have been made on chain. And how old they are, because we've got this lifetime, max lifetime to manage. And then it will effectively interact with the chain in order to reflect the desired set of allocations on chain. And right now, this loop is quite simple in that, for any allocation that needs to be, say, closed and then reopened, so we want to continue indexing this subgraph, it actually executes two separate transactions to do that. So it will first close the allocation and then reopen the allocation. And similarly, for claiming query fee rebates, it will send one transaction per allocation that it's claiming for. And so the efficiencies really come down to batching interactions. So Indexer Agent today, you really have like a one-to-one mapping between an interaction with the protocol, like closing an allocation, and transactions. And so if we can batch together many kind of individual protocol interactions, like opening or closing and opening an allocation into a single transaction, there is a fair amount of gas to be saved for each interaction that we include in the batch. Now, the on-chain contracts actually already have functions to facilitate this kind of optimized interaction. So the two kind of main the main functions that I'm looking at are close and allocate and close allocation many. And if we kind of visualize what making that reconciliation loop smarter might look like, if you've got the old set of allocations and the new set of allocations, there's going to be some set of overlap between the subgraphs that we were indexing before and the subgraphs that we want to continue indexing. And so for those subgraphs, it makes a lot more sense for Indexer Agent to do a close and allocate in a single transaction rather than closing and opening each one with two separate transactions. Similarly, there's going to be some set of churn in the subgraphs that an indexer decides to index, right? Like bad subgraphs are going to fall off, and great subgraphs, as perhaps they're surfaced by the curation market, are going to kind of surface, and new allocations will need to be opened for those. And this loop might look a little bit smarter like this. So rather than submitting a single transaction for each allocation that we want to close and not reopen, we can just close all of them in one batch with close allocation many. And then for any subgraphs we want to continue indexing, today we'll probably implement a replacement where we essentially send n number of close and allocate transactions. So we'll cut the number of transactions in two. And then potentially in the future, we may introduce new batched interactions. So the ability to open many allocations in a single interaction with something like an allocate from many function, and maybe even a close and allocate many to batch together all of the close and allocates into a single on-chain transaction. So this is an example of close and allocate actually being used on mainnet. This particular one was closed and reallocated 9 days ago, and I think that's maybe the 4th or 5th reallocation that has been done that way, and that's consistently saving about 10% in gas usage just by batching those two interactions into one transaction. Work on simulating, a kind of more comprehensive set of scenarios has begun, and for anyone interested, I'm using Brownie and Ganache to do that. And initially, this is going to be used to just test different subgraph churn scenarios and the kind of impacts of batching in different ways. But this is also cool because we can use this to test theoretical contract upgrades. So if we wanted to introduce new batching functions, we can actually do that inside the simulated environment and get fairly concrete numbers around what the gas savings would be before actually going down the GIP process. I just want to say thank you so much to the foundation. Being funded to work on really interesting problems is awesome. And I just say to any other contributors that are interested in getting involved, apply for a grant. It may feel daunting, but the team is really friendly and the process is a lot more simple and smooth than you might expect. Thanks again.
Awesome. Thank you so much, Chris, and to all of our grantees. I couldn't have ended it off with a better note. I think we've run out of time today for Q&A. So if you have any outstanding questions, please head to the forum and EdgeNode Foundation and other teams can answer them. And we'll make sure to end off with some Q&A time next time. I think that's it for now. So thank you everyone for joining us for the second Protocol Town Hall.
Thanks, everyone.